Hey, what's going on, everybody? Welcome back to my object-oriented programming course with me, part-time adjunct, A. Louis. Today I want to talk about compilation in the Java language. We're going to go into the architecture of what happens from going from compile time of Java source code to the actual application that's actually running on your desktop. So let's take a look. I got my trusty little iPad here where I can draw some stuff, and I hope you enjoy it. So as we take a look here, I'm gonna draw some pretty pictures, and hopefully it'll make sense to you. So this little box we're gonna call the Java source code. So we'll just say Java. Sorry for my handwriting. And the extension for this file is going to be .java. This is what you're going to be writing in this course. You're always going to be writing source code, and the language that you're going to be writing the source code in is Java. The source code will get fed into a program called a compiler. Okay, so we'll draw another box here. We'll call this the compiler. And this compiler is going to take your source code and convert it into what we call bytecode. And then the bytecode is going to get fed into another program called the JRE. Call this a Java runtime environment. I don't have enough space to write it, but you call it JRE. Again, that's a Java runtime environment. And what this does is it's going to validate everything, that everything looks right in the bytecode. Now, the bytecode itself is Java specific, and it's specifically made so that it is multi-platform compatible. And what's going to happen is when you generate your compiler code, compiled code, which is bytecode, you're going to get something called a .class file. And this is what we call a compiled code. Okay, so I'll say .class here. Sorry about that. And inside the JRE is actually something else called a JIT. Which is called it's abbreviated for a just-in-time compiler. And inside the JRE, this just-in-time compiler is going to create native OS code. So this will output native code. And when I say native, it's going to be machine language code, which is native to the OS. So we can say native OS. The compilation process is different than a C++ program or anything that's native to the operating system, because Java has something called a Java virtual machine, call it JVM. So you can say that everything from the line that I've put is part of the JVM, the Java virtual machine. And for you to compile Java source code, you first need to install this Java virtual machine on your desktop. Now the JVM is available to you for Windows, for Mac, and for Linux. And what that does is that if you write your source code in Linux, I can take your source code, compile it, and I can run it on a on a Windows machine, and I don't have to retweak your Java source code at all. So this actually over here, what you've written stays intact. I don't have to rewrite it at all. That's a difference than if you write a program in C++, because if you write a program in C++, a lot of the machine code is native to the OS. For example, if you use Visual Studio to create a C++ program, that's going to create an executable that will run on the Windows machine, but it's not going to run on a Linux machine. On a Linux, you would have to tweak it here and there for it to run. With Java, it's different because once you write your code using the Java compiler, which is part of the JVM, the compiler will take the Java source code and compile it into bytecode, as we see in my really crappy diagram. It's going to compile into bytecode, and then that bytecode will be fed into the JRE, which contains the just-in-time compiler, and that takes care of converting your bytecode into native OS code. So let me give you a kind of another picture of how this would look. I think this is a better graphical representation of how it sort of looks in terms of the process when you compile a program. The compiler that Java uses is called Java-C, so Java compiler. The Java source code, which is here, we start out here, right? So you're going to write out your Java source code in a Java language. You're going to run Java-C on that Java file. That's going to compile your code, and then it's going to generate the .class file, which is what we call the bytecode, right? So the Java bytecode is specific to Java. This is all specific to Java. There is nothing native to the operating system that you're at, but it is native to what we call the Java virtual machine. Now, the bytecode itself will now go through some processing through the JVM, which is the Java virtual machine. And if you look on the bottom here, we have the OS X, Linux, and then Windows. Every operating system, you have to install it before you try and run a Java program. Will need to have a JVM installed. Windows, you can click on the Oracle site, and they'll give you a link to install the Java virtual machine. And then you can run any program that's written in Java. Linux the same, and OS X the same. So what's going to happen is you're going to get a class file that's going to run through what we call the JVM, and the JVM will eventually convert the bytecode that it's fed into native code. And this native code belongs to all the type of OS calls that are needed to run on a Windows machine or a Linux machine or the Apple, the OS X. So if you're going to run a Java program, the first thing you need to do is install the JVM, and then along with that, it'll install the Java compiler, and then you'll be able to run any type of Java source code on your machine. Now, what's happening in this class is a little bit different, but it's still we can still take the same infrastructure that we have here, but just apply it on the web. So let me show you what's different. So what Replit has done is it actually taken this painful process of installing the JVM on your machine, which could be good and bad because maybe you want to go in and understand how it works and how you can install it on your machine. But for the sake of simplicity for this class, and I don't want you to waste too much time on installing a local compiler, we're going to use Replit, which is an online compiler. And if you see on the right, the compiler already is installed on the Replit servers. What Replit is running is they're running a cloud, a Java VM cloud, and they probably have a couple of machines that are running the JVMs so that it can handle the load of everybody compiling code at once. Because your class is not the only class that is going to be compiling code on Replit's servers. And what they provide to you is, if you see on the left, that's you, right? Smiley face, right? It's me. Sorry. You have a web user interface, and then you're going to be able to write code on the Replit user interface. And as you write the code, this little arrow here is sending the source code through the internet, and it's going to compile it on the Replit servers. So essentially what they've done is they've duplicated multiple machines. They've installed all the JVM software, and then once they have that, then they can send back the output after they compile. So every time that you run a compilation on your side, you're actually doing a Java C here. That you're sending a Java C command along with your code. Okay, that's being sent over to Replit servers, and then they'll handle the rest. They handle all the JVM compilation, and then they'll send back just the result or output, which is, I think it's going to cut the learning curve in terms of setting up your virtual machine. And anything you can do locally, you're going to be able to do on the Replit server. So it's a great tool. And again, I want to give you a background. So there is a little difference in terms of running compilation locally versus what we're doing in this class. That's why I would like for you to open up an account on Replit, and then you can look at the examples that I do online together. And this way I can also share the links of code that I write on for the course. On the next video, I'm going to show you how to run a Replit Java program. We'll start out with a hello world, and then we'll talk about all the background knowledge that you should be aware of in Java. See you on the next lecture.